Okay, I think we'll begin now. It's always interesting to have sort of the sessions at the end of the day. Everybody's rounding third and getting ready to conclude the day, but we'll try to get through the material as quickly as we can and as efficiently as we can and leave a little time for questions here in the session as well. Thank you for coming. Thank you for attending the conference. And we also want to thank Mentor Graphics, our partner, for including us in this particular event. This session, just to make sure everybody knows the session content and title, is the Hypervisor technology and multi-domain system. So we're going to focus on embedded virtualization and the hypervisor in the automotive space for this particular session. I'm going to move through things pretty quickly because there's a lot of material that I want to try to cover, and again, leave time for questions at the end. I'll introduce you to who we are and who I am. My name is Kerry Kleeman, and I'm the Vice President of Worldwide Sales in charge of global sales and distribution for Open Kernel Labs. Open Kernel Labs is clearly the world's leader in embedded virtualization software. Our software is currently shipping in more than 1.6 billion devices. Currently, we were founded in 2006, but we have a very, very deep research and academia history. The technology itself goes back to the University of Karlsruhe, Germany, also IBM's T.J. Watson Laboratories, and University of New South Wales in Australia, where we have a deep research-based heritage. We were born from a think tank in Australia called NICTA, or known as National ICT Australia. NICTA was started by a number of PhDs and researchers, and also funded to the tune of about $500 million by the Australian government to evaluate, analyze, and commercialize and incubate technologies from Sydney, Australia. OK Labs has been winning the high ground in some very key vertical markets, which we're going to talk about in this session. Most recently, we want to announce that we've announced the launching of defense-grade smartphones, tablets, and other communications devices for the government sector. So the idea is to take high-grade security or a high-assurance framework and put that on commercial, off-the-shelf smartphones and tablets to provide government employees, military employees, the ability to have secure and restricted communications, but on a commercial off-the-shelf device. We also launched our Automotive virtualization solution. We've been quietly working with Robert Bosch, Car Multimedia, for the last several years, and earlier this year we announced their go-to-market strategy with the OKL4 microvisor for automotive virtualization. And these are just some of our customers and partners at this time. The automotive industry is being pushed clearly to more closely follow the greatest trends from the consumer space. And it's becoming increasingly important that the car multimedia systems are not quickly outdated by innovation in the consumer space. Drivers increasingly expect to have the same kind of functionality that they have on their smartphones, that they have on their tablets, that they have in in-flight systems and at home, also in the car. And part of that narrative more closely follows consumer trends while we're introducing open application environments, even application stores, into the head unit. However, and there's always an however, the automotive market has very different requirements for safety and quality than the consumer space, such as mobile. As a mobile consumer, if I get a couple of bugs on my system and need to reboot it or need to clear the cache on my iPhone and start it again, it's really not that big of a deal. And that's very much opposed to the standards and expectations of the automotive industry, in the automotive space, the automotive world. And some of the specific security challenges presented by the desire for more open environments clearly are application security, platform security, and strict and significant isolation between operating systems and embedded systems, as well as connectivity or communications in the car. And that's what we're going to talk about. OKL4, that's the name of the hypervisor, or what we call a microvisor. OKL4 provides a framework for architecting embedded systems as a set of execution containers, or what we call secure cells. Each cell can run its own operating system or even individual device drivers or applications. You've got control over and granularity in terms of what you want to put in a cell. And each cell, you can configure what system resources that cell has access to and what rights that cell has for communication with, for example, other cells. You could, for example, specify that an Android cell does not have direct access to the CAN controller hardware. That's just one example. Only the OKL4 microvisor runs in the privilege mode of the processor. And it needs to do that because it's responsible for enforcing the access control policies in your system, whatever your system requires. How does it work? How does virtualization work in the automotive sector? OKL4 effectively tricks the operating systems running in the cells into thinking that they are running directly on the hardware. That's what it does. In fact, though, the operating systems are only interacting with virtual resources, and OKL4 itself manages how to access those virtual resources, and those are mapped to the physical resources on the processor. And lastly, in addition to the OKL4 microvisor providing the framework for conducting this, it also controls the communication between cells, coordinating power management between the cells, and sharing devices between the cells. That's just a basic primer on what virtualization does and how it operates. Now, the automotive ecosystem, and now we're going to talk about 4 or 5 key use cases in the automotive space. The automotive ecosystem continuously, like other ecosystems, engineers new products and product lines. And over time, the ongoing product life cycle leads to a history, an evolution of very complex hardware and software technologies and configurations. And this kind of product development can lead to dead ends and result in the requirement to rebuild things from generation to generation. With virtualization, you have a very, very clear upgrade path. You have one that preserves the legacy investment that you've already made and allows you to rapidly incorporate Linux and other application environments very easily and at a very low cost. Another use case for virtualization, and almost universally across the mobile wireless space and the automotive space, is the requirement for security and robustness. Isolation of security-critical functions or security-critical software from a potentially, in fact, a likely untrusted open operating system is very crucial, key, and critical. And it has to be done with something that minimizes the trusted computing base with which it provides. The OKL4 microvisor is very tiny in footprint. It's a little bit less than 12,000 lines of code in its entirety. It's the only piece of software I've seen that from release to release and evolution to evolution of the software, it actually reduces in size and reduces in footprint. Therefore, the attack surface area and the opportunity for exploits remains smaller and smaller. And it reduces the burden of certification and recertification because it's the only thing that's operating in privileged mode. Another very key use case that has application across markets and target vertical markets for OK Labs is separation for licensing and intellectual property protection. With OKL4 and with virtualization, applications, middleware, drivers, and even entire operating systems with incompatible licensing or some conflicting IP requirements, they can be run effectively and safely on a single processor and still comply with very divergent licensing requirements. And this strict separation allows for a more flexible architecture and a more flexible build of the software stack. And OKL4, or virtualization, accomplishes this feat with very strict address space isolation among the software components running in user space, with only OKL4 infrastructure executing, again, in privileged mode. Rich operating systems like Linux and others do a great job for supporting rich functionality. However, their real-time performance is limited, to say the least. Automotive systems have, as you know, strong real-time requirements. For example, the responsiveness to CAN messages or real-time traffic detection cannot be met by a Linux or an Android. These real-time requirements are traditionally met in the automotive space. How? It's by employing a dedicated microcontroller and running the real-time operating system such as OSEC on that dedicated microcontroller. Virtualization changes the game. It allows and provides the automotive manufacturers and those that are providing solutions in the ecosystem to, to design the systems that include Linux and meet the strongest of real-time requirements without the need for additional hardware complexity, hardware design, and hardware cost. Direct savings to the bill of materials. The OKL4 microvisor provides the benefit to be able to do that by supporting the construction of systems that provide Linux and a real-time operating system running side by side. And this ensures that the RTOS can provide fast interrupt latencies independently of the workload running in Linux. You get the best of both worlds. Another very critical and very key use case for virtualization in the automotive space is something we call Fastboot. Fastboot will allow one or more cells to be loaded independently of the initial OKL4 boot image. As Android kernels can be quite large, or a Linux kernel can be quite large, having it off of the critical path of system startup improves the boot response time. And OKL4 will offer this stage loading of its cells, so cells with fast startup requirements, they can run independent and be loaded before cells with weaker startup requirements. So you have that separation and that granularity of control over what gets power, what gets resource, and when it gets the resource. And we've got an example of the separation of Linux and the CAN bus, the cell boots with on top of OKL4 immediately, and then the Linux kernel is loaded after CAN begins and starts to operate. How does it work? Virtualization will offer the Tier 1 suppliers and their OEM customers a rich set of capabilities that they can use to build reliable and robust IVI systems. So these dedicated virtual machines will isolate core automotive functions from application environments. That's really the key, and that's what we're doing. Support for stage boot and independent reboot to give the core automotive software fast startup times, or what we call instant-on systems or instant-on requirements. And also hosting of multiple OSs or OS instances for simultaneous support for Geneva, clearly, for Android, and for AutoZar environments, all optimized on the latest ARM Cortex processors. I'd like to share a quote. It comes from a recent press announcement. This press announcement was issued jointly by OK Labs and by Robert Bosch Carr Multimedia Group. Building IVI systems with OKL4 can benefit the Bosch technology portfolio with strong separation of open application environments without compromising reliability, commented Dr. Andre Zahir, Vice President, Automotive Navigation and Infotainment Systems, Robert Bosch Car Multimedia Group. Bosch selected OK Labs for next-generation IVI systems. OKL4 performance and security are hard to beat. As in the mobile wireless space, OKL4 will help Bosch deliver a robust and sophisticated in-vehicle user experience with the added bonus of lower systems costs. And that's just a proof statement from a major supplier in the automotive space and in the automotive market that is betting on virtualization and betting on the hypervisor to enable their next generation IVI systems. Okay, so I'm going to repeat myself a little bit, but it's designed to reinforce the salient and basic capabilities of the hypervisor for automotive. The OKL4 hypervisor supports strong separation and management of consumer apps, whether it's multimedia or infotainment, and core automotive functions, navigation, driver assistance, and the like, on one processor, including any advanced multi-core chipset environment. It supports staged boot and independent reboot for instant-on systems. You're able to meet all of your real-time requirements traditionally required for an ECU, separate and independent of the workload in Geneva and open OSs. Applications that can be virtualized are virtually limitless, no pun intended, and the hosting of multiple OSs for simultaneous support of Geneva, Linux, Android, and AutoZar, and all done with power management in mind. This is just an example of the value of who realizes the value. A tier 1 supplier will realize the value of the Fastboot application and potentially be able to reduce the bill of materials cost by anywhere between US dollars $4 to $5 by eliminating the dedication of a microcontroller for that process and for that function, reduce the design and complexity, improve portability and maintainability, and that's what Fast Startup will provide to the Tier 1 supplier. CE Firewall application provides tremendous value to the OEM by providing robustness, serviceability, and protection, and then providing an environment that's isolating the automotive and consumer environments on a single processor. These topics, by the way, are discussed in a lot of detail in a number of white papers that are available. You can go search and navigate our website if you'd like, but we also wanted to make it a little bit easier for you, so we provided cards on the table here, and if you fill those out, we'll send you the relative white papers that discuss automotive virtualization in significant details with block diagrams and with a lot of case studies. And I've got those here. Some of those are on the table. I know some of you already have those and filled those out, but we'll make that available to you if you fill out the card. I'm going to start to summarize here and say that the key benefits of virtualization are really key and critical and simple. Safety and reliability, by allowing those that are developing in this space to enable the latest consumer technology trends, innovations, and integrate those without interfering with the core automotive functions such as navigation, rear view camera, driver assistance, and the like. It can help you materially reduce cost by consolidating functions such as driver assistance, CAN, and most networking, and also even instrument cluster onto the IVI application processor. And it'll establish embedded virtualization as a way to address key Target 1 automotive supplier challenges, which we think are consolidation of vehicle control networking and IVI in a single head unit, and then also the preservation of instant-on and safety-critical behavior with consumer-facing technologies and applications, which we know need to be served up in the vehicles more and more. This is the very short summary. We're supporting the inclusion of the latest consumer electronic trends for all of the rich multimedia applications, content, and user experiences without compromising at all on safety, reliability, and robustness. We're reducing the BOM via ECU consolidation, and we're providing the consumers with more customized user experience. I know I went through this pretty quickly, but I am at the stage now where I can open up the room for any questions, comments, or anything else that anyone would like to talk about. Yes?
So you're saying single processor, single core, or does it work better on a multi-core situation, or?
Yeah, so the question was single core. The answer is yes, but obviously support for a multi-core processor. We're supporting features and capabilities like dynamic SMP, load balancing on those multi-core processors, and clearly you're going to have more horsepower. But there are use cases, and the technology is going to market in single-core instantiations as well. Yeah. I think in the back, yep. Yeah, you bet. The question was, what about trust zone and hardware-based virtualization that's evolving rapidly and will be available in newer releases of ARM Cortex-based processors. We have a deep and long-term relationship with ARM. We spend a lot of time with ARM routinely. And even in ARM's implementation of hardware-based virtualization, we've sat down at the development lab with ARM to talk about how the two technologies can and should remain very complementary. We get access to ARM roadmap information kind of in advance of it being available by virtue of our partnership with ARM. You'll find fundamentally that the two are complementary, that hardware-based virtualization has its place and can serve as a container for one thing to be happening in it, but software-based virtualization opens it up more so, and the hardware-based virtualization can even run in a software-based virtualization cell. So the technologies are very complementary. We work very, very closely with ARM to do that, and we're on all their early release programs for their roadmap, and we try to line our roadmap with theirs. I think they're complementary, and I think you'll find a good place for both of them as you build and design systems. Yes?
What do you have to touch inside of the GAS operating system, especially on chips that don't provide hardware virtualization of the specific peripheral?
Yeah. There are a finite and very small number of modifications that have to be made in order for our kernel to communicate and interface with the OS. That's right. That's right. Yeah, that's the answer. And by the way, the white papers that I'm referring to that are available to you give you a subset or an example of what those limited modifications are when pair virtualizing. Yes?
Besides ARM, I'm wondering, are there other processor families that OKL4 is ported to, such as PowerPC?
Yeah. So we have experience on Intel platforms, but it goes back to an earlier version of the OKL4 microvisor, what was then known as the OKL4 microkernel. And the microvisor is a new and much more significant implementation technology and product. So we haven't done Intel yet with the OKL4 microvisor, but that's on the table and probably will happen as a result of customer demand and customer requirement in the very near future. We have experience with MIPS, and then there's always a requirement or two for PowerPC and for other environments, but for us, it's sort of based on customer demand and roadmap acceleration. Certainly can be done, and has been done. Yes. I'm sorry. Could you repeat it? Yeah. Does that have a code name? Does that have a Kingfisher? Kingfisher. Yes. So the answer to your question is yes. And to give you technical detail on how and what and when, I'd need some help from my compadres to make that happen. But we'd be happy to follow up with you. Okay, great. Thank you. Make a note, if you don't mind, on there. I'd like to understand your Kingfisher integration implementation.
Do you have any obligations to support or address ISO 26262?
You bet we do. So we're ambitiously following and moving along with Geneva. So we're now part of the Geneva organization, and we're increasingly trying to better understand the requirements of the market from a standards point of view. So it's on the list. I don't know when it's coming, where it's coming, but we know about it, and we know we'll need to. What other questions?
How would you compare yourself to others in the market, like Wind River and like Integrity by Greenhouse?
Sure. I think the three things that are product-oriented and technology-oriented that we would point to that would take a little time to walk through with you would be performance, security, and maturity. I think emphasis on maturity. OK Labs has been doing this for quite some time. We have production implementations in the market. We'll be in cars in production through our relationship with Robert Bosch and a few other suppliers in the market very, very quickly. In the mobile wireless space, we're widely deployed and widely adopted. So this is what we do. It's our focus. It's a point solution. It's what we're dedicated to. I think our R&D teams for virtualization and for the hypervisor would rival and match anything that the other guys and gals are putting onto this market. I think as a bare metal hypervisor, as a Type 1 hypervisor, there's some differences between a Type 1 and a Type 2, and some of the other hypervisors in the market espouse to a Type 2 mentality versus a Type 1. That information is readily available in the white papers we'll send to you. But I think mostly we've figured out performance. It's not uncommon for us to do bake-offs when in evaluations against Green Hills or against Red Bend or against Wind River, and in every instance we've been able to outperform. The performance penalties for the benefit that you get are negligible in some instances of a virtualized version of Linux. Linux is actually running faster para-virtualized than it is independently. So we've had time to figure out how to optimize for efficiency and for performance. And those would be the things I'd point to. Thank you. Yes?
Comparing like an AutoSAR with Linux or something like that, how does it work that, you tell us that the AutoSAR is more time critical than the other one?
In the OKL Form Microvisor, we have a set of APIs and mechanisms for setting the policies for priorities. And so those policies for your priorities for resource get implemented in a system admin type console that allows those priorities to be set and established, and that's how that's done. It's in a user interface, parameter-driven administration system, and then the OKL Form Microvisor takes control, schedules where the resources go and when they go and what has priority. We have a project currently for WinCE. We have Android in the mobile and smartphone and tablet market. We did virtualization of Symbians a number of years ago with a project that we had with Nokia and ST Ericsson. And you know, there's a list of others that are coming, and certainly that we're not precluded from doing, you know, any open OS or any proprietary RTOS. We have a wide range of RTOSs that have been virtualized, and you know, there are a number that have been virtualized by us and then some by our customers as well. How are we doing on time, Scott? 4 minutes. Okay, great. Very good questions. Very good questions. Are there any others? Well, if there aren't, I'll conclude by thanking you for your time, thanking you for attending this session, and encouraging you to fill out the card. And we've got a set of specific white papers on virtualization in the automotive space that we'll provide to you, make it a little easier rather than navigating through the wheelbarrow of information that's contained on our website. So thank you kindly, and enjoy the rest of the conference.